Okay, lesson 3.8, we're going to talk about experiments and inference, like how do we decide if it's meaningful or not? Okay, so first we're going to talk about how to outline an experiment that uses a completely randomized design. We're going to explain this concept of what does it mean to be statistically significant, and then we're going to use simulation to see if things really are statistically significant. Okay. So a completely randomized design, we kind of talked about this a little bit, but we have this random assignment that we've talked about and the sizes of the groups and the treatment they receive. We want to just kind of sketch it out a little bit more. So basically, if you remember, there was one that we talked about caffeine. We had 20 volunteers, and this is how you can sketch out the design. So what we start with 20 volunteers. We're going to use random assignment to randomly choose to put them into one of two groups that will receive the treatments. So we have this random assignment of the treatments to the groups. Okay, so we had talked about you could use slips of paper or a random number generator, and we wrote that out, how to do that. But we would have random assignment into group 1 or group 2. Group 1, we would give the treatment of caffeine, and group 2, we would give the treatment of no caffeine. And then at the end, we would compare the change in their pulse rates. Okay, so that's how you kind of sketch out a completely randomized design. So the completely randomized design, basically the experimental units are assigned to the treatment completely by chance. So right here, when we're assigning them into their groups, this is a completely by chance, pulling names out of a hat on a piece of paper or randomly choosing a number, that sort of thing. Okay, so here's a problem. Let's see, I'd like you to try and do this by yourself first. Okay, is talking on a cell phone while driving more distracting than talking to a passenger? So David Strayer and his colleagues at Missouri University of Utah used 48 undergraduate students as a subject in the experiment. The researchers randomly assigned half of the students to drive in a simulator while on a cell phone, and the other half of the students to drive in a simulator while talking to a passenger. The response variable, what they're measuring, is whether or not the driver stopped at a rest area that was specified by researchers before the simulation started. So could they remember that they were supposed to stop at that rest stop? Okay, we're going to outline a completely randomized design. Okay, so we're going to think, what do we start with? Okay, we're starting with the 48 volunteers. Okay, what do we have to do with them? We have to randomly assign them to two groups. Okay, so we have 24 students in one group. We have 24 students in the other group. Okay, what's happening to those groups? One is going to be talking on the cell phone, and one is going to be talking to a passenger. And then at the end, we're going to measure the proportion of people who stopped at the rest stop. Okay, so that's your randomized design, just mapping it out what's happening. Okay, that's object number 1. Lesson object number 2 is, what does it mean to be statistically significant? Okay, we talked about this a little bit the other day, but if we get a sample, is it significant? Okay, or could it have happened by chance is basically what we're trying to think about. Okay, we talked about the magnets, right? A doctor identified a painful site on each subject and asked him or her to rate the pain. They had an envelope with a magnet or not a magnet and at random, and gave the mixture, then chose the magnet and applied it to them. And afterwards, they also, rated the pain 0 to 10. How was the pain? Okay. So in this problem, we had a group of people, and we had a random assignment, and we had two groups, those with the magnet and those without the magnet. Okay. And then at the end, we came together, and the difference in pain rating. Okay, so that's kind of the design there. So if we only had 50 patients, it's unlikely that these would be exactly equal. But remember that random assignment is trying to get two different groups that are pretty much alike, so that it can eliminate the other confounding variables, right? But by chance, is it possible that the active magnet group, right, with the magnets, would it be possible that they included a higher proportion of patients who would gonna feel better no matter what treatment they got? So it's possible. Okay, so we try and equal it out, but it's not always going to be equal. So that means we have some differences, right? So sometimes when I take this group of people and I put them out, let's say that if everything was exactly the same, okay, they were given the same treatment. Some people would say they had more pain relief, and some people would say they have less pain relief. So every time I randomize these people into these two groups, I get different groups, I might get different results. Okay, just because by chance. Okay, when I just by the chance of which group they're in. So we have some variability here. Okay, in our results. So basically, what it means to be statistically significant is, do I get a result that is so different? Okay, so if I assume there's no difference between the two groups, okay, there's no difference. Well, you can't see what I'm doing there. Let's say there's absolutely no difference between the pain relief from the people with the magnets and the people without the magnets. There's no difference. Let's say there makes no difference. So no difference. Let's say this is the no difference line. I would just by random assignment get some that have good pain relief and some that don't have good pain relief. They're all around here, right? But if I get a result that is so much different than what I would be expecting if there's no difference, that would say that it's probably unlikely that this is true and that this is true, so that there is a difference. That's what we mean by statistically significant. Okay, so the definition: when we have an observation difference in response between two groups in an experiment that is too large to be explained just by the variation in the random assignment, we say that it's statistically significant. Okay? So if I have this group and I have this group, okay? Notice we have some variability with all of them, right? We have a resulting difference. Okay, so group A with the active, they had pain improvement of 5.24. Remember, they had to rate their pain from a scale of 1 to 10, right? So they improved by 5. The other group, the inactive magnet, only improved by 1.1. Okay, so the difference between the two, this group with the magnet improved 4 points more than what the other group did, over 4 points more. Okay, now could that have just happened by chance? Or is that really significant? Did the magnet really work? Okay, so you can see the different spreading out of the different with a magnet, without a magnet. Okay, so let's explain this idea of significance. Okay, so remember we read about one study. They took 22,000 doctors, and they randomly assigned them either to take an aspirin or to take a placebo, okay, every odd day. Now, they also, this is new, hoping to find that the aspirin helped the heart attack, okay, the new part. These doctors also randomly assigned to take beta-carotene or a placebo every even number of days. So they're kind of doing two experiments on these doctors, okay? So if you think about the design, they have 22,000 doctors, okay? They have this random assignment into group 1 and group 2. Group 1 was given the aspirin, and group 2 was given the placebo. And then at the end, we're measuring the percent with a heart attack. Okay? Now, let's take that one first. The proportion of doctors taking aspirin who had a heart attack was smaller than the proportion of them that taken the placebo. So less people had a heart attack here than there. Okay? The difference was statistically significant. So it is statistically significant. So what does that mean? Okay? It means that our results here, no matter how they were designed, right? If you take these 22,000 people and I put them randomly into these groups, I would have different results, right? Depending on who's in what group. Okay? I got a result that was so much different than what would be expected that it is significant. Okay, so we would say this. The difference in the proportion of doctors who had a heart attack in the two groups was too large to be due just by chance variation. Okay, just variation here, just by taking these doctors, put them in different groups. Let's say I had all the people that I don't think would have a heart attack would be in this group, and all the people that would more likely have a heart attack in this group. You're looking to get rid of that because of the random assignment, right? But let's just say by randomness it happens. You would get some results, right? Okay. We got a result that was so much different than what would be expected just based upon that part. Okay. Now, part B. They took those 22,000 and they did a random assignment into group 1 and group 2. And group 1 got the beta carotene, and group 2 got a placebo. Okay? They then did the percent that developed cancer. So they wanted to know if the beta carotene helps prevent cancer. Okay? Now here it says it was not statistically significant. Okay? So let's say we gave them both a placebo. Okay? There's no difference between the groups. If I put the 22,000, 11,000 here, 11,000 here, we're going to have a difference between the two groups just because, of other characteristics. So they might get that result. Now, if I do the random sample again and put another 11,000 here and another 11,000 there, I might get a little bit different result. If those 22,000 people, a different 11,000, a different 11,000, right? I'm going to have some variability, okay, every time I do that random assignment, okay? Now, if it's not statistically significant, that means I got a result that was somewhere down in here that could have just happened by chance. It might have just been because of the way these people were randomly assigned, okay? Whereas if it is significant, it's not just because of how these people were randomly assigned, it's because of the aspirin. It is significant. The aspirin made a difference. Where here, it could have just happened by chance. The beta carotene, even though they developed less cancer, it could have just happened by chance. It's not significant. Okay? So in words, the difference in the doctors who developed cancer in the two groups was small enough that it could be due just based upon chance variation of how people were assigned. Okay? Okay, third. Okay, so how do we get whether that is statistically significant or not statistically significant? Okay? So we're going to do the pulse rate for caffeine group. Okay? So we had this random assignment. We had, 20 people, and random assignment into the caffeine group and the no caffeine group. And we measured their pulse rate. Okay, so there's kind of the design, just simplified design. Okay, so those people that had caffeine, these are those people, and they took their final pulse rate minus their initial pulse rate, and in everyone's pulse was higher after they drank caffeine than before, right? They're all positive, where these people didn't change at all. The mean change is 3.2 beats per minute. Now, those that didn't have caffeine, some of them had higher pulse rates final. Some of them, if they're negative, had higher pulse rates to start out with than final. Okay, so it varied a little bit, but their average change was 2. Okay, so the difference between these two groups was 1.2. Okay, so the caffeine group versus the no caffeine group had a mean of 1.2 beats per minute higher. Okay, now, is that significant or not? Okay, so if we were in class, I would do a little experiment. Okay, so here's number 4, here's number 1, here's number 2. Okay, I have, for all 20 of these people here, I have a piece of paper with their result on it. Okay, now let's say that these are all shuffled up, and we put them into, okay, so they got it put into these two groups, right? Okay, let's say this is group 1, this is group 2, this is group 1, this is group 2. Group 1, group 2, group 1, group 2, group 1, group 2. See, it's just randomly done. I mixed them up Just randomly assign them group 1, group 2, group 1, group 2, group 1, group 2. Okay, so now, just by random assignment, I have two different groups. I could find the mean of this group. I could find the mean of this group, and then I could subtract it, just like they did here with this. They found the mean of this group, find the mean of this group, subtract it. I could do that with this. Okay, and I would get a certain result, right? The difference between them, let's say there was no difference between them, okay? So I have one at 0. Okay, I mix them all up again. Okay, I take them, I mix them up really well, put them in a hat or whatever. I put them out again in 10 and 10. Okay, there's a group of 10 and a group of 10. I would do that randomly. And let's say the mean of this one and the mean of this one had a difference of 1. Okay, and I can do that over and over and over and over and over again. Okay, so here is sort of a computer simulation of that. So this means at 0, there was no difference between the two groups. At 1, right, that means there was a difference of 1 between the groups, difference of -1 between the groups, etc. Okay. Now, notice just by randomly mixing these up, you know, kind of the mean, the average is that there's no difference between the groups, right? Okay, so that's sort of the middle of our graph. So we're assuming that there's no difference between the two groups. Okay. Now, sometimes, just based upon how these are all divvied out, how the random assignment is, sometimes they'll be lower and sometimes it'll be higher, just by chance. Okay, so let's see. The result that we got was over here with the two groups, we had a difference of 1.2. Could that have happened by chance, or do you think it's because the caffeine really made a difference? Okay, so here, 1.2 would be right here. What we're going to do is we're going to count how many are there or greater out of all 100 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, 19. We had 19 out of the 100, which would be 19%. Okay? 19% got this 1.2 or bigger difference. Could that have happened by chance? Pretty likely, or not? Yeah, okay. So almost 20% of the time, that could just happen by chance. If there's no difference between the groups, just based upon how I randomly assign them, right? If I randomly assign them here or here, I could very easily get 1.2 or greater just based upon chance. So it is not significant. Okay? Now, let's do another example. Here are the results of a distracted driver experiment. Okay, those that stopped at the rest stop, of those that are on the cell phone, 12 out of the 24, so half of them did. And then if they have a passenger with them, 21 out of 24 did. Okay, 21 out of 24 was almost 88%. So 88% versus 50%. Are cell phones more distracting than passengers? Okay. So yeah, I mean, based upon this experiment, 88% versus 50% you're more distracted, right? Okay. But is it significant? Could it have just happened based upon how these people were randomly put into groups? Or is it really happen? Okay. Is it really the cell phone that's making the difference there? Okay. So here is, okay, the difference in the proportions. We said 21 out of 24 was almost 88%, and 12 out of 24 was 50%. Gave us a difference of 37.5%. Okay. Now, here's a simulation. If there's really no difference between the groups, just based upon how they're put into the groups, we'll expect some lower and some above, right? Some right around this area. Did we have any in our simulation that had a difference of 0.375? Okay. 0.375 would be out here. Did just by chance, did we get any that gave us this result? No. Okay. Difference of 3.75 is greater or greater. Never even occurred in the simulation, right? The difference is significant. Okay. The driving with a cell phone was or is more distracting than having a passenger. Okay. Based upon that group of people. Okay. It did not just happen just by chance. It's kind of proven that the cell phone is more distracting. Okay, so where is that? Okay, so this one we had 0 out of the 100. There's 100 dots there. 0 out of the 100 is, it never happened, right? So it's significant. And 19% could have happened by chance. It was not significant. Okay. Now, where is that line? Where do we know whether it's significant or not significant? Okay. What we use is we basically use an alpha of 5%. Okay. So if it's above 5%, we say it's not significant. If it happens less than 5% of the time, we say it is significant. Okay. So that 5% is usually our cutoff point for that. Okay, so next one. To see if fish oil can help reduce blood pressure, males with high blood pressure were recruited and randomly assigned to different treatments. Okay, so we have a group of men with high blood pressure. Okay, there's random assignment, and they're put into either treatments. Okay, 7 of the men were randomly assigned to a 4-week diet that included fish oil. Okay, and 7 other men were assigned to a 4-week diet that included a mixture of oils that approximated the types of fat in a typical diet. Okay, so that's just kind of our control group, right? We want to see if the fish oil does better. Okay, at the end of the 4 weeks, each volunteer's blood pressure was measured against what they had before. So we then measure blood pressure. Okay, so they had a certain blood pressure, and they either ate the fish oil or the regular fat, and then we tested their blood pressure medicine, blood pressure, and then see the change from before to after. Okay, so is it significant that this group improved over this one? Okay, we want to see here. So, completely randomized design. We kind of did that right here, right? There's our design. Number 2, calculate the mean reduction. Okay, so we got to find the mean of these two groups. So this group right here, find the mean 8 plus 12 plus 10 plus 14 plus 2 plus 0 plus 0. Divide that 1, 2, 3, 4. There were 7 of them, right? So that group had a mean of 6.57. And this one, 0 plus 1 plus 2 plus negative 3 plus negative 4 plus 2. Divide by 7. Okay, so negative 1.14. Okay, so if you think about these numbers, we're taking the fish oil minus the mixture, right? So this group, their blood pressure was better. Okay, this group, their blood pressure was not good. Okay, it actually got worse by eating other fats. Okay, so the difference between the two groups, so we use 6.57 minus negative 1.14. The difference between the groups was 7.71. Okay, now, does that difference between these groups, is it significant? Or could it be because of how the people were randomly put into the groups? Okay, so here's a simulation. They did it 100 times. And we got a difference of 7.71. So 7.71, there's 7. Let's say there's 2 of them. So there were 2 out of 100 that had a difference of 7.71 or more. Okay, which comes up to be 2% of the time. Is that more or less than 5%? Okay, it's less. It's less likely. So 2% of the time is not very likely to happen at all. Therefore, we say that it is significant. Okay, that fish oil does reduce blood pressure. Okay, now if it was more than 5% of the time, it could have just happened by chance, and we say that it would not be significant, and we can't prove that fish oil reduces blood pressure. It might have been a little bit less, but we can't really tell if it's because of that random assignment. Okay.